So today's topic is Azure Serverless Architecture with Azure Functions. So in this webinar, we will see what exactly a serverless architecture is. Then we will see how we can utilize Azure Functions for the sake of implementing a serverless architecture. So the agenda is what is serverless? We will see some cloud features. Some of them you will most likely be already aware of, especially if you have used cloud features in the past, for example, AWS or Azure, etc., and so on. Then we will discuss the advantages of using a serverless architecture, then the various development tools which we can use for the sake of developing serverless architecture or Azure Functions, basically. Then we will have a look at the supported languages. There are lots of options. You can use whatever major language you want for the sake of writing a serverless architecture application. Then lastly, we will see Azure Functions triggers and bindings. They are very important components of serverless architecture in Azure Functions. Okay, so let's start off with the serverless basics. So what is serverless? Serverless, it's a very popular term these days, especially if you have heard of AWS Lambda or Azure Functions itself, or IBM OpenWhisk, Google Cloud. They're all promoting serverless architecture these days. Serverless computing, it's a code execution model, which means where exactly or how exactly your code is running. Like traditionally, we get to install some operating system like Windows or Linux, etc., and so on. Then we install some application server, and after that, we get to deploy our application, and then we get to test it out, etc., and so on. But serverless is radically different. You will later on notice that you basically create an application and you just upload it to the cloud, and that is it. So it makes the application deployment very easy and very rapid as well. So you get to have your application up and running in very short time. Basically, that is a major benefit of using serverless architecture. Server-side logic in case of serverless architecture is usually stateless. If you have heard of microservices architecture is very similar to this serverless architecture concept in a sense that they both suggest we should create microservices, smaller services that should ideally be independent of each other. Or in other words, they should ideally be stateless in nature as well. And all these serverless-based applications that we get to create, they are event triggered, which means when exactly you want to execute your application. So are you waiting for some user to type in some URL, or are you going to read some or monitor some file on the hard drive in the cloud, or are you going to monitor some database in the cloud and read up the values in case of your desired values you want to execute some operation? So in short, serverless applications, they are event triggered. You can configure the event when exactly the application should be executed. So I'll talk about that. Plus, I'll also show you a demo as well later on in this webinar. And usually serverless applications, they run in ephemeral compute containers. All it means is we have containers, like if you have seen or used Docker containers, it's very much similar to that. So we basically have containers, they get created and destroyed on the fly or automatically. So all these cloud vendors, like in case of Microsoft Azure Functions, when we implement Azure Functions, Microsoft will be creating and destroying these containers. In case of Amazon, AWS, Lambda, um, the containers will be created and destroyed automatically for your serverless-based applications. So basically, the applications, they run in containers. And that is also one of the characteristics of microservices architecture as well. So usually when you create a microservices architecture where you have a bunch of services, smaller services that are independent of each other, they all usually run in separate containers so that there are no overlaps and they should be independent of each other. You should be able to take down one instance or one container without affecting any other service, etc., and so on. So that is a very important characteristic of serverless architecture as well, that your applications, they run in these temporary compute containers. They are very similar to Docker containers, basically. And they are automatically managed by a third party, like in case of Microsoft, it's managed by Azure. In case of Amazon, it's managed by AWS, etc., and so on. So basically, when you utilize serverless architecture, your main focus will be on the application, not on its management. So as developers, you have to learn a new API because each cloud vendor will ask you to learn a different API. You will have to memorize a bunch of functions and classes, methods, properties, configurations, syntaxes, etc., and so on. But once you learn the syntax, after that, you just have to focus on that, and you just upload your application and it will be available, it will be accessible. You won't have to worry about the management. You won't have to worry about configuration of your servers, etc., and so on. So serverless architecture, usually it is also known as functions as a service. Let me explain this functions as a service in more detail. In order to understand functions as a service, we should be aware of some other cloud features or other cloud terms. You will most likely be aware of some of these terms, like infrastructure as a service, platform as a service, software as a service, and we usually have function as a service as well, which is our main scope of this particular course. Infrastructure as a service usually means if you use, let's say, Amazon AWS, or you use Microsoft Azure, you basically want to set up the virtual machines. Then inside the virtual machine, you want to install some operating system like Windows, Linux, etc., and so on. Then you want to install your development tools like JDK, .NET Framework, some other application servers like Apache Web Server or Tomcat, WebLogic, WebSphere, etc., and so on, database servers, and so on. Then you start writing your code or develop the application, and you make the code available as a web service or a REST service or something like that, and so on. Like in case of .NET, you can use a WCF-based service or ASMX-based SOAP service or a REST service. So it's up to you, what type of service you want to use. So in case of infrastructure as a service, hardware is managed by the cloud vendor. Virtualization will also be managed by the cloud vendor. All we have to do is we have to say we need to provision a virtual machine with so much RAM and CPUs, etc., and so on. And then after that, we have control over that VM, and then we can install the operating system, install whatever runtime or development tools or JDKs, etc., we want to install, and so on. Then we can develop our application, and we can make the application available as a web service or as a REST service, etc., and so on. So in case of infrastructure as a service, the last two components, they are managed by the vendor, by the cloud vendor, whereas the rest of the things, they are managed by us, by the users of the cloud. Likewise, if you use platform as a service, or you use, let's say, Azure or AWS as a platform as a service, then you're saying the cloud vendor should be responsible for providing you the hardware and the VMs, and it should also already have some OS as well. It should also have the runtime or certain development-based toolkits, etc., and so on. All you want to do is you want to create your application, deploy it, and make it available as a service. So for example, Say you want to create a website which would have a database, and that is it. And you also want to sort of make it available as a web service as well. So if you do not plan on creating any VM at all, you just want to write your application on your local machine and upload it either by using FTP or whatever technique you want, HTTP, etc., and so on. You simply upload your application files, like it could be an ASP.NET MVC application or PHP application or something like that. And you also store your data in the cloud in some database like MySQL or something like that, and so on. Then basically you're using the cloud as platform as a service. You're not setting up the VMs, you're not installing the OS, etc. You're not installing the runtime toolkit, etc. and all. And you're just uploading your source code and storing your data, etc. and so on. Now, before we discuss functions as a service, which is the main scope of this course, let's quickly discuss software. For example, if you use SharePoint Online, Office 365, where you have MS Word, PowerPoint, and all that stuff and so on. So in that case, you don't have, or you are not responsible for anything at all. All you have to do is you have to create a user account and start using the application as an end user. You're not a developer, basically. So in case of software as a service, everything is managed by the cloud vendor. Hardware, VM, OS, runtime, application services, functions, etc. Everything is managed by the cloud vendor. So in the past, we used to say that cloud offers infrastructure as a service, platform as a service, and software as a service. But now we have this fourth option as well, which is known as functions as a service. And simply put, all it is, it's a web service. You create a web service without bothering about what application server I'm going to use, how I'm going to configure that application server, how much RAM I should provide to it. So you don't have to worry about the management of the application server, basically. You just focus on the source code of your application or the logic, basically, which will act as a service, basically. And that service can be made available to the public users, or you can just use it internally so that just your cloud-based applications should make use of it. So simply put, functions as a service is sort of a service. And why do we use the term functions here? There are two reasons. When you write your code, in most cases, you do write a function. So usually you do write classes, and inside the classes, you get to write the methods. So they are sort of functions. And there are other ways as well where you don't have to write a class. You can write the function right away. That is also possible because there are various languages that are supported by functions as a service, which I'll talk about later on. But in short, it can be a function literally, like in a C sharp, in C sharp, it can in some other language like PHP and so on. So it can be a function. Or the second reason why it's called functions is that it is basically providing a functionality. It's the implementation of your logic, basically, and you're making it available to either the public users or to your internal cloud-based applications. So in functions as a service, you don't have to worry about hardware, virtualization, OS installation, installing the development toolkits and all that stuff, setting up the application servers, and so on. You just basically write the code, upload it, that is it, and it will become available. So serverless, usually it can be at times a bit misleading term, because serverless sounds like you don't need any server at all, which is not entirely true, because in the cloud, it is making use of a physical server, which we don't have direct control over, but in the cloud, there is some server. So usually a more appropriate term for this concept is application-less or application serverless. So basically, we are not responsible for installing or managing any application server. We are just responsible for writing the code, upload it, you're good to go. So application-less or application serverless, that is a sort of a more appropriate term for this concept. So again, simply put, it is nothing but just sort of a service. And you don't have to worry about any management of the application server, etc. at all. So I'll come to the practical portion in just a bit, where you can practically see how it looks like and so on. Before that, let's have a quick overview of the advantages of serverless architecture. So serverless architecture has pretty much the same benefits that are provided or that are available if you use microservices architecture. So microservices architecture, like I mentioned, that in a nutshell, it is a bunch of services that are small in scale, that are also independent of each other, and they run in a totally different isolated container. It will have the source code, the binary files, the database for that particular server or for that particular service in a different container. So each container will host its own small database, small service, etc. So for example, if we have an ERP solution, and we have different modules like inventory, payroll, accounting, and so on, each module will have its own separate container with its own database, with its own service, etc., and so on. Microservices itself is a pretty huge area, but whatever benefits are available to us when we use microservices architecture, same benefits are available to us when we use serverless architecture, because each service is basically independent of each other. You can still make the services talk to each other if you want, but overall they are independent of each other. Serverless architecture also makes the application more scalable, because we are, after all, using the cloud, and the cloud is highly scalable. So rather than buying your own physical hardware, etc., to make your application more scalable, you're relying on the public cloud. And you can easily say you want to utilize so many servers or so many resources, etc., and you can make your infrastructure more or application more scalable. You can spread out your application geographically as well if you want. And it results in reduced operational costs, because as you recall, I mentioned that you're not responsible for the management of the application servers at all. So you will have to spend less time on the management, more time on the development, making things work basically. It also reduces the overall cost involved as well, because you get to use pay-as-you-go model. So if your services that you have written, they are used a lot, then you get to pay more for that usage. If they are getting used less, you get to pay less for that, because it's pay-as-you-go model. Because after all, public cloud vendors like AWS and Microsoft, etc., they don't have fixed billing in most cases. They just charge us by using this pay-as-you-go model. And serverless architecture also results in faster deployment as well, because there is no application server to manage. You just get to write the code, upload it, you're done. So deployment is much faster. Whereas in traditional applications that are monolithic, that are huge, for example, if you have a WCF application or service, you will have a bunch of DLL files. And if you modify even a single line of code in C#, then you'll end up recompiling the DLL file, and potentially there could be long time involved in recompilation. Then you will have to redeploy the entire application to make it work. Whereas in case of serverless architecture, They are small services, so you can modify each service separately without affecting the other service and so on. And like I mentioned, that it's easy to update because unlike the monolithic approach, you don't have to redeploy the whole thing. You just redeploy what you have modified. So it speeds up the deployment. It's easy to update. Another major benefit of using serverless architecture is that each service can utilize a different technology stack, which in a nutshell means each service can be written in a totally different language. So if someone is good in C Sharp, that person can write the service in C Sharp. If someone is good in PHP, that person can write code in PHP. Likewise, there are other languages. You can even write services in PowerShell, Bash shell scripts, like Linux-based scripts and so on. So there are lots of options available, basically. And overall, no one will know that you have used a different language. They will just get to utilize the service in exactly the same way without knowing what language they have used under the hood. That's another major benefit of using this particular approach. Whereas if you are using WCF-based service in .NET applications, if you have created a project in C Sharp, then the whole thing has to be in C Sharp now. All the services, all the interfaces, the contracts, they all need to be in the same language. But in case of serverless, each service, each function of a service can be in a different language. Yet another benefit is that it's totally open source because it's based on Microsoft's Azure Web Jobs SDK. And since it's open source, so what it means is that you will not get vendor locked in at all. Because you can take the exact same SDK, you can take it to, let's say, Amazon's AWS. You can provision a VM, and then inside the VM, you can install this SDK, and you can make your Azure functions available there as well, even in Amazon's AWS. So in order to deploy your Azure functions, you can utilize Azure Web Jobs SDK, which comes with the Azure Functions runtime. You can deploy it on premises as well. You can install it on your local machine, and you can make your Azure functions available in exactly the same way as Microsoft is making these Azure functions available in the public cloud. So this is a very useful benefit that you don't get vendor locked in at all. So you can start creating your traditional REST-based services or WCF or SOAP-based services by using this serverless architecture concept, which is known as Azure Functions. Development-wise, we have lots of options. You can choose to connect to Azure Portal, and without using any development tool whatsoever on your local machine, you can simply use this portal, use its own built-in code editor. You can write the code there, and you can have your services up and running. Which also means that you can be on your tablet. You could use some Android tablet, your iPad, etc., even your cell phones, etc., if you want. So as long as you can access the portal, you can access the development tools that are available directly inside the portal. So this is exactly what I'll do on my side. I'll show you how we can develop Azure functions by using the Azure portal. Otherwise, you can also use other options. For example, you can use Azure CLI option, which means you can install the Azure CLI on your local machine. Go to your command prompt and execute a bunch of commands to create Azure functions, upload files that you have on your local machine, the code basically, the service code, and deploy them to the cloud. You can also use Visual Studio. Visual Studio has a template. So if you go to File, New Project, you can go to the Cloud section. There you'll find Azure Functions option. But in order to use that, you do have to ensure that you install or update Visual Studio along with Azure SDK. And you don't have to just use Visual Studio. You can also choose to utilize Java as well. Like you can use Eclipse IDE along with Maven in order to create your Azure functions and deploy them written in Java. That's yet another language which is supported by Azure Functions. You can also use Linux shell, bash shell scripts if you want for the sake of developing your Azure Functions. So in a nutshell, Azure Functions, they are nothing but just web services. So we get to learn a new API for it, and you don't have to worry about what application server to use. You don't have to use IaaS or any other application server whatsoever. That is all managed internally by Microsoft. We just have to focus on the code, just upload it, just save it. That is it. Languages wise, like I mentioned previously, there are lots of languages supported by Azure Functions. So we have C Sharp. You can also write Azure Functions in JavaScript, F Sharp, Java, Python, PHP, TypeScript, Batch, PowerShell, and even more languages will be added to this list in future. So that is the beauty of Azure Functions. You write the services in a more modern way. Uh, and functions will ensure that you get to utilize microservices architecture. Your services will be small in size. They will be independent of each other, and they will be more scalable, etc. Each service can be written in a different language. You can use it on your local machine by installing Azure Function Runtime, or even in Amazon's AWS as well if you want. Now, before I show you some demos, a couple of important concepts that we should be aware of. So Azure Functions triggers. So, so Azure Function, you can think of it as either a class with a bunch of functions, or at least one function, which should be executed as a service, which should be able to take some parameters as input. It should be able to process the request, and it should be able to respond back with some output. That is what the services do. They usually take some input, process it, and respond back with output. So Azure Functions, they are no different. Now, question is when the Azure function will be executed, what data it will receive, and how it will respond back. So for now, we will discuss when it is executed or how it's executed. So trigger means you get to specify some event which will determine when the function that you have written will get executed. And the benefit is that you don't have to hard code the details. Like you don't have to, like in C Sharp, you must have seen event-driven programming where we get to specify event name, then we get to use plus symbol equals, and we get to specify the event handler for it and so on. So here we are trying to do something similar, but without hard coding the details. We are going to configure it in a sort of a declarative manner. We will specify a configuration file, and we will just link it to some event. So triggers wise, we have various options. Some of the commonly used options, they are webhook, which is very similar to saying that when someone types in some URL, then it should execute your service. So execution of the service can be controlled based on the URL that you have typed in, or it can also be based on some timer. You can say, let's say on daily basis at midnight, you want to execute your service automatically. It should read some data from the database, perform some operation, dump the data in some other database or whatever. Or you can also choose to use service bus as well. Service bus is available in pretty much all public cloud vendors solutions. We actually also get to use it in on-premises environment as well. Service bus, think of it as sort of a queue. If you have lots and lots of services and you receive lots and lots of requests on daily basis, then it can become difficult for your service services to process such huge amount of data in a very short amount of time. So if there's a huge traffic, then you'll want to ensure that none of the requests are lost and they're all fulfilled. So for that purpose, we get to create a service bus, which is sort of a queue where we get to streamline, store all the requests, and then the services can start reading those requests one at a time, fulfill the request, respond back, and so on. So you can also specify a service bus as well, so that when a new message is posted to a service bus, then the service should read the data and it should get executed basically. And there are tons of other options as well, like you can monitor. So trigger, you can also think of it as sort of monitoring some source, so that when it's modified, you want to execute your function. So you can monitor or trigger the execution of your Azure function based on some text file as well, or based on some database as well, and so on. Then another concept we should be aware of is Azure Functions bindings, which means that, like I mentioned, that Azure function should be able to receive some input parameters. It should be able to process it, and it should be able to respond back with some output. So input and output, what input you want to send to the function and what output it wants to send back to the user or whoever has executed that particular function. So bindings wise, again, we have lots of options. So for example, you can say you want to, once you have received the data from some user, like say if someone is trying to use a URL and trying to pass the service some parameters, then once you have received this input, you can process it and respond back by saving the data to some text file or to some database, or you can send it back to some queue or like service bus, etc., and so on. Basically, there are lots of options available. You can control from where you want to receive the data and where you want to send back data back to, or the output to. Configuration wise, we get to create a JSON file. Usually it's named function.json. I'll show you this file practically in just a bit. And output wise, or even input wise, it can be pretty much anything. It can be external file, it can be a database. Database wise, you can optionally utilize Cosmos DB if you want. I'll give you a quick overview of Cosmos DB in just a bit before I show you a demo. So let's discuss one more thing before I show you a demo as well. In the cloud, it's up to you. You can choose to use SQL Server if you want. There's Azure SQL available. It's sort of SQL Server in the cloud. You can definitely use that. But one of the issues with SQL-based approach is that it can be somewhat slow because it's transactional in nature. It supports transactions, and you always have to use SQL language only, and you always have to store data in relational format, in a tabular format. It must have a certain number of columns. Each field must have a certain data type, etc., and so on. So it has a fixed structure, basically, which is fine. In quite a few applications, you will know the structure. You will know exactly how many columns you're expecting, what data type you expect for each and each column. So in most cases, but there will be cases where you might not be aware of how many columns we will receive from the user. What will be the data type? So you might not be aware of the schema, basically. So when you're not aware of the schema, in that case, we can choose to use NoSQL based databases. So NoSQL means not only SQL, which basically means that it's not necessarily relational. It is not just a tabular data store. It can contain any type of object. It can contain data in JSON format. It can contain number, string, Boolean, array, object, have any number of columns. There are no fixed data types for each and every column at all. So it's sort of a free form structure. There's no predefined schema basically. You get to define the schema later on when you want to consume that data. But when it comes to storing the data, you can say, I want performance. So performance-wise, you can start receiving the data, save all of it in this Cosmos DB, which is a NoSQL-based approach. It's a very, very fast database. It can literally accommodate the entire world's data, so the entire population, how many people are there, 7.5 billion or something like that. You can store absolutely terabytes worth of data, and it's very, very fast as well. Uh, so it's very popular, especially if you are planning on using big data. Big data is another very important term these days, which basically heavily relies on NoSQL-based data storage concept a lot, where we don't have predefined structure or the schema, and we get to define the schema down the road once we want to consume it. So Cosmos DB is a very fast database, basically. It has full integration with Hadoop. Um, you can also choose to say it should be saved on the storage to make it more persistent, or you can say that, no, I want to keep it in the memory only to make it even more fast, um, plus to cache the data in the memory. So if you have sort of lookup data to utilize, you can cache it in the memory, so it's always fast to access it. So there are lots of benefits, and due to lack of time, I cannot go through all the details, but Cosmos DB is definitely becoming very popular, especially if you are planning on using Microsoft Azure. It does have support for transactions as well, if that is what you require, but it ends up using snapshot isolation for that purpose. But usually out of the box, we don't use ACID transactions or transactions in short. We just use NoSQL structured-less or schema-less sort of approach to make it very, very fast. And then later on, we define the schema when we want to consume it. Okay, so basically here we have discussed some concepts, what serverless architecture is, Azure Function. We discussed that it's a way provided by Microsoft to implement serverless architecture, and storage-wise, you can choose to utilize Cosmos DB, which is a very fast storage basically. And down the road, if you have used this Cosmos DB, you can dump the data to some SQL Server, to Oracle, to MySQL, or wherever you want. So definitely that can be done as well. Then let me show you a demo on my side. I've already set up things because usually provisioning things can be a bit slow, and it's a very short webinar. So I've already set up a few things on my side. Okay, so when you connect to your Azure portal, if you want to create a new function from scratch, you can go to create a resource, then go to compute category, and here you can click on this function app. So function app got introduced just recently because all cloud vendors have introduced this concept recently. It's not a very old concept. So click on this function app. It will let you create a function from scratch. I'll not recreate a function from scratch because it does take a bit of time to provision it. So I'll just point out the high-level steps here. So give your application a name, and this will be sort of your public address, which you can use to access your serverless architecture-based application. Specify the region, etc., and so on. Then after that, click create, and then once you're done, let me go to function app. Or you can also click on this all services, click on this function app. I've already added function app or app functions to my favorites as well. Okay, so here I already have a couple of functions, or think of these as services basically. One service is making use of Cosmos DB for storing the data. The second service is not utilizing any storage whatsoever. So let me start off with a simpler service first of all, before I show you the more advanced one which utilizes Cosmos DB. In case if you want to create a new function from scratch, you can click on this plus button here. It will ask you what type of, or when you want to trigger, or when you want to execute your service or the Azure function. So you can utilize timer trigger, which means every so many seconds or minutes or hours or whatever the duration you want to use, uh, you want to execute a certain function. You can also monitor some queue. If you want, you can monitor the databases like Cosmos DB, etc., and so on. You can also monitor Internet of Things, IoT. This is very useful if you have some um, sensors connected and configured with the cloud environment. For example, you could have your thermometer or even your home automation system to your cloud environment, like your uh, air conditioning, your television, your other entertainment devices, and all that stuff. It's security alarm, etc., and so on. You can connect it to your cloud environment as well. So you can monitor pretty much any type of source, or based on some trigger you can do anything basically. So here you can choose to use, let's say, HTTP trigger. I've already done that on my site. I already have this one here. So when you click on this one, you can also choose the languages as well. If you use this portal, by default, you can only utilize C#, F#, and JavaScript. But if you use either Visual Studio or you use Azure CLI, etc., and so on, then you can utilize more languages as well. Okay, so let me go to this HTTP, or actually let me go to this simple function for now. So each entry here is essentially a web service. It's another thing that we don't call it a service, we call it Azure function. This is the code that I've used here. I've used C# for now. Here we are using asynchronous programming coding style, which is very, very essential when we create these functions. They all need to be asynchronous. We do not want to hang up any instance at all. So we want to make sure that things keep on running in the background. So for that, we get to use asynchronous programming style. We are able to receive the input by using this force parameter, HTTP request message, and we're able to write some message to the trace or to the log file if you want. So here, for now, I'm monitoring. Let me run it. So notice that it lets us test our service here. So it's currently smart enough to know that we have used a parameter named name. So this is a parameter that we are going to receive here, or it's sort of your input basically, or sort of the request. So we want to receive a request sort of variable named name. So if this is found, then we want to obtain its value and we want to perform some operation on it. And actually we are able to receive the input in two ways, either by using the query string, or we can also choose to receive it as part of the request body as well. So you can choose to click on this parameter. Let's change it to get here for now. Then we can change this to, or we can specify the name here and specify a value if you want. For now, let me switch back to the post option. Delete this one. I'm just going to use this request body. So I'm expecting a parameter named name, and here I can specify whatever value I want. Let me change it to something else here. Now, if I execute this application or this function manually for now, it will show us the response here. Whereas in the real world, we'll want to obtain the service URL, which is this one. I can take this URL, copy it, and then we can give it to any other developer or to some other to some other developer, so that the developer can make a request to this particular service function. So here we will have to receive name equals whatever. So we have sent a request, and then if you go back here, somewhere here you'll be able to see the response as well, and so on. So basically we can obtain the service URL if you want, and then make the service call, which is basically sort of a simple, oh, sorry, I made a mistake here. It's not supposed to be a question mark, it's supposed to be ampersand. That's more like it. So here we can see this hello world message. I've duplicated the message here. So basically, we are able to call this service via the URL, just like we are able to call our regular REST service. And the major benefit of using this approach over the traditional REST service is the way we are managing this particular service. There is no application server here to worry about. It is just a function uploaded to the cloud environment, and it's acting as a service automatically here. You can definitely configure things. For that, you can go to view files. Here it will show us the actual source code, which is this run.csx file right now. And configuration can be made in this particular function.json file. Here we can specify when it should respond. So we are using HTTP trigger here, what methods you want to support. We are supporting both get and post for now. We are supporting HTTP protocol for now, and so on. So basically, you just have to worry about the configuration file and the source code. Just upload all the files here, and each function will act as a separate service without worrying about what application server to use. Let's start up the application server, let's manage it, and so on. So right now, I just received the input, I processed it, and just displayed it or returned it in a very simple way. Whereas in a more complex scenario, you'll want to utilize the bindings like input binding, output binding, and so on. So for that, we usually click on this integrate. Then here we have this outputs. We can bind it. We can say we want to send the output to some external location. Like we can send it to Cosmos DB, we can send it to some table, we can send it to some queue, we can save it as a file on the hard drive, and so on. So there are tons of options here. You can even send SMS messages to cell phones, etc. as well if you want. So there are tons and tons of options. Okay, so if I go back to my service here, this one is already configured to use Cosmos DB. So here a file, let's say, show you the code first of all, then run it. So here I've already configured this application. I'm going to create a record. I already have a database named Hockey in my Cosmos DB, and I'm going to create a new record where I'll end up having player ID, player name, and games played. So these are the three columns or fields which I'm expecting for a record, basically. Again, for testing purpose, for now, we can choose to click this run. We can specify the values either in this request body, or we can also choose to change it to get and specify the values here. So let's say if I entered some values, let's say whatever. If I run this one, it should send the data to Cosmos DB. I'll show you the Cosmos DB in just a bit. Before that, let me also show you the URL-based approach as well. If I click on this one, I can obtain the URL, give it to some developer, and that developer can utilize this URL as a service URL in any type of application, like in Node.js, jQuery, Angular.js, C#, Java, PHP, etc., and so on. And here I can use player ID equals whatever, player name equals whatever, games played equals whatever. So we have sent a request to the service. It should have processed it. For now, I'm not returning any response here. Instead, if I go to my Cosmos DB, which is also hosted in the cloud environment, I should be able to see these records here. So let me search for Cosmos DB here. We should have the data stored here. Data Explorer. Okay, so here we have this Hockey database. For now, I didn't name the table. I've just named it my collection. Then here we can go to documents. We should be able to see these records. These are the IDs of each record. If you have used MongoDB, which is another NoSQL database, it also generates the IDs like these, and it stores the data in object format, JSON object format like this. then it can be consumed in pretty much whatever application we want. So here we can see the actual values. So we have Crosby here, we have Niedermeyer here. I actually have a couple of Niedermeyers, one with ID 99. Then we also have this ABC and so on. And then later on, we can choose to save this data in SQL Server-based database, Oracle, or we can choose to consume it by using Apache Hadoop, which is a big data-based technology, and so on. So basically, simply put, Azure Function is nothing but just sort of a web service. And you don't have to worry about how to deploy it, where to deploy it, and how to manage the server. You just have to focus on the code, just upload the code, things will happen magically. It will become available as a service. And due to the nature of Azure Functions, each function is very small in size, which represents a separate service function. And all these services, they run in separate containers. They are independent of each other. So they make the application more scalable. And we are making use of microservices architecture as well, which is a very common practice these days. Okay, so WebEdge also offers various courses as well. So on Azure, we have a couple of developer-oriented courses. Plus, if you have any custom requirement, feel free to contact us. We can always provide you some more custom options as well. You guys will have access to these PowerPoint these slides later on. Okay, so any question regarding serverless architecture concept, Azure Functions? Okay, so thank you very much, guys. It was a pleasure to be here with you for this webinar. Have a good day.